Welcome to my fifth tutorials. I've been doing lots of tutorials on this on Tinkercad project. As I said earlier, I'm starting from this so because I love seeing things work and I love seeing how things come to play. So I have more projects up my sleeves. I'll have like up to 20 more projects that I will get you guys through. So make sure you subscribe, like, and comment, and make sure you stay tuned to my channel so you can see more of my projects. So today we are working with a you can see the connections, the LEDs green, blue, red, yellow. So you can just simply change the color by typing, then you can see list of colors here. So change the colors. So I used green, blue, red, and yellow. So it's connected. It's a very easy connection, but I will still, maybe in another video, I will make out time to show you guys how and why all the connections work the way they work. And we are also working with a new component this time. You can go to your basic components and search for a photoresistor. This right here, a photoresistor. So this is like it's like a map. It's giving a value to something, a data value to something. It's just more like a potentiometer that we did in our last video. So the photoresistor, it's cool, but it's not as fun as the things I have more of my sleeves with other components, because I have lots of things to show you guys. So make sure you take time to do the connections exactly. Don't make mistake. The 5 voltage must be connected to the plus positive, and so it works properly. And the GND, just this GND in this power, this GND will be connected to the negative. And most of the time I use this as red negative, but we'll just keep it as black for now. So firstly, let me just, because I want to create a project of, as we increase the terminal for this, it's just like working with binary. So to make it more understandable, understandable, more fun for you guys, I will just have to add the components, the binary components to the place. Okay, it's 1, 2, 4. Okay, I think it's it. I think that's it. Okay, so this is the binary component. So what we are working on now, I will just shift this a little bit so it doesn't. I hope you guys are through with the connections. You can take a picture of it from the beginning of the video so you don't make mistake with the connections. Yeah. So so this is my code. I will just increase the increase this so you guys can see it very clearly. Okay, collapse this. Okay, so this is the code. It's connected to, and this time we are working with analog, or the light sensor. The light sensor is connected to analog 1. You can see it in our connection down here. Analog 1 for our connection from our breadboard to our Arduino R3. So this is it. So you have to declare the connections. You can see in all my tutorials I declare the connections at the top. And light sensor connected to A1, the data is initially set as 0. The green is connected to 8. The blue is connected to 13, like right here in the Arduino R3. So if you check your connections, make sure it's the same thing. 8, 13, 12, and 7. So this is the void setup. You must have a void setup to make it work. And again, we got another input, the light sensor. The light sensor is an input. So the input is this light sensor. So we are going to be printing something to the monitor, to the serial monitor, this serial monitor that we have done. in our last video as well. So the P mode green, it's outputs, all of them are outputs. The green, blue, red, and yellow LEDs are output. So this is our void loop. So all my code, just like we will still reach like in a part of the function as we are creating more, as I'm showing you guys more projects. We'll reach in a part where we'll have to start declaring many functions to make it work properly. Don't worry, it will be getting more fun. But as for now, we are starting with the easy stuffs with less code. And so this is just it. So I'm sure if you're watching my video, you have an idea of what an if and else statement does, because if you don't, then you're cooked. So that's the most, like, it's the easiest thing to learn, the if and else statement. So just make sure you have a knowledge of this. So this is it. So you must use this, since we are working with a photoresistor, this yellow body right here. So you're working with him, so you have data map, data, exactly the same writing, the data, then 6 to 679. These are the values, but the whole values that can be there. But we are working with only 0 to 15. 0 to 15. Since why we are working with 0 to 15 is so we can just give a very clear example. Like you can see 8, 4, 12, and 1. So I think if you calculate it, 8 plus 4, 12, 14, 15. So we are working with 0 to 15. So these the light values. So what we are trying to do now is, if the data is greater than or equals to 8, the green LED stays on. If it's greater than or equals to 8, the green LED stays on. This high means on. If I haven't explained it in details before, this high means on and low means off. So if it's greater than or equals to 8, then the green LED stays on. Then the value of the data that we initially set as 0. So if the data is greater than or equals to 8, it stays on, and this subtracts, the data subtracts by 8. So it doesn't display any other value. So else it just stays off. So we do the same thing for blue as well. We do the same thing for red. We do the same thing for yellow as well. So if you can see, we have many ways to get this. We have many ways to get the same functionality. We have like you can just be like, if data is equals to 15, like if data is equals to, so you know that in programming language we don't use assignment operators like for equals to or if statements. So we use like uh comparison operators, like if double equals to this thing. So 15, you can tell it the colors to display. 15, it display this one stay on, this one stay on, this one stay on, and this one stay on. If it's 14, this one stay on, this one stay on, this one stay on, this one stays off. If it's 12, this one stays on, same thing, and it keeps going. But if for just lower code, we just did it this way, but you can do the longer way and still get the same functionality of the code. So I'll open my serial monitor to start this up so you guys see what I'm trying to explain here. So if I just start this simulation, the light value is initially 0, because if you remember, we're working with 0 to 15. So if I go to this photoresistor, any value I put into it, like if I hit this, so it's 8, the value is now 8. So 8 is green. So green, only the green light is on. So if I hit this, you see it's 11, then the green light stays on, the red and the yellow, you see the blue is off. So that's why I put these letters, these numbers, I mean to say, this number, I mean to say, so you can identify it very well. So it's 11, you see 8, 2, and 1 stays on, green, red, and yellow stays on. So if we hit another value, 13, so we have green, blue, and yellow. So if you calculate it, is 13. So 8 plus 4 plus 1 is 13. So you can, let's move the value to, I think, 15. So you see 15, everything is on 15 because it's our last value. It's our last value. So you can just have fun. You can add yours. You can do anything. But these just ideas of things you can do and real life practices you can work on yourself. So I say that is it. So make sure you like, comment, and share to your friends and impress just maybe your girlfriend or anything. Just impress people with this. Yeah, because we need most, like, you have to learn this to be able to do most of the connectivities. We are still going to go in more things, remotes, buttons, and many other things on how to create many things with Tinkercad and write code, and you see how things come to functionality. So make sure you drop a comment of your code, a good comment, a any comment. Just make sure it's good and nice and says impressive stuffs, please. So thanks, and thanks again for watching and staying to the end of this video.